In today's video, we'll be going over how to use the derivative in order to find function information. To start off, we're going to find the derivative of our function g of x, which is 2x cubed minus 12x squared plus 18x. To start off, we're going to use the power rule in order to find the derivative, and if you want to know how to use the power rule, you can find it up here in the corner, or you can go ahead and check out the last video on the channel. So to start off, we are going to use the power rule, and we know by using the power rule that our derivative is 6x squared minus 24x plus 18. And we know that we can factor this. So if we factor it, it'll come out to 6 times x minus 3 times x minus 1. Okay, so now that we have our derivative, so we're going to just write that, hey, it's a pretty dark color. Hey, this is our first derivative. This is basically what we're going to be using for the majority of this video. So our first step is to find, the first step for these types of problem is to find the derivative, first derivative you could say. And our second step is going to be finding the critical points. And this is going to be from the derivative itself. You're just setting the derivative, I'm just going to put this in parentheses for reference. Derivative, you're setting the derivative equal to 0, and that is how you find your critical points. And then your third step is to sub values into derivative, and you'll see how these steps play into these questions. So let's go ahead and do our first problem, where it asks, is the function increasing or decreasing when x equals 5? So when you have a question like this, you're going to substitute this value, x equals 5, or this value of x, which is 5 here. You're going to substitute that into your derivative. And we said our derivative is 6 times x minus 3 times x minus 1. Substitute in our value of 5, as we said before. So this is where step 3 is playing in, subbing values into derivative. So we have 6 times 5 minus 3 times 5 minus 1. So now we have 6. Now I'm just going to simplify the parentheses. 6 times 5 minus 3 is 2, times 5 minus 1 is 4. Let's finish up parentheses because PEMDAS. So we have parentheses, we have 6 times 2 times 4, as we know, is 8. 6 times 8 is 48. Now the main thing you want to remember, and I'm going to write it up here in orange, the sign equals increasing or decreasing. So basically, let's write it. So we have a plus. This means we have a positive number, positive value. After you substitute it into your derivative, this means you are increasing. And if you have a negative or a negative value, you are decreasing. That is something you should write down or try your best to remember when dealing with derivatives. Now we know that after substituting a value of 5 into our equation, that we get 48. And we know this is a positive 48. We had no negatives. So this means that our function is increasing, as we said here. When you have a positive value, it's increasing. So we have 48. So meaning our function is increasing when x equals 5. So our answer, let's write this in red. It is increasing because we have a positive value. That was easy enough. So let's go ahead and do B. And B is asking, find the interval on which g of x, which was our original function, is increasing. And here you can see that obviously we don't have a value like x equals this or x equals that. We just need to find an interval between this point and this point. It's increasing, and at this point and this point it's increasing. So B and C have a similar process, that we must remember that the sign is what determines if it's increasing or decreasing. So let's write out the steps for this type of problem. So our first step is to find the critical points, and we're going to go through how to do that in just a minute. And then second is to make a timeline. make a timeline. Third, we are going to mark the critical points on the timeline. Mark critical points. And then 4, we are going to get values from all intervals. And you'll see what we mean in just a moment when we start B and C. From all intervals. 5 is to, oh, so weird, 5. 5 is to substitute, and 5 is to substitute the values into the derivative. Okay, so let's go ahead and start B first and then go ahead to C. So to find the critical points, as we said at the beginning of the video, you're going to set your derivative equal to 0. So let's write our derivative down here. And we know our derivative, let's do this one in teal. Let's just one in a light green. So we have 6 times x minus 3 times x minus 1. And we're going to set this equal to 0 to find critical points. So we're going to set this equal to 0. So this is just, we don't want to care about this that much, but we're going to set this equal to 0 first. So we have x minus 3 equals 0. Obviously that's 3. And then we have x minus 1 equals 0. And that is just 1. And if you just want to know how to do it, you're adding 3 to both sides, which leaves you with x, meaning that x equals 3. And here you're adding 1 to both sides, meaning that x equals 1. So now that we have our critical points, let's go to step 2, which says make a timeline. So let's make a timeline in blue. So let's make a timeline. So this is our timeline right here, pretty basic timeline. And here we're going to mark our critical points, as we said in step 3, mark critical points. Let's go ahead and do that. So we have a critical point of 1 and 3. So 1 is first, then 3. And whenever you're making your timeline for this type of problem, you must remember to include a negative infinity and a positive infinity. Those are going to be very important when dealing with these types of problems. And step 4 says to get values from all intervals. What this means is that we can see that we have an interval from negative infinity to 1. We have an interval from 1 to 3. And we have an interval from 3 to positive infinity. So you want to get some value that falls between each of these intervals. Between negative infinity and 1, I just call that interval number 1. Let's get a value from there. And let's just say that we chose negative 3 here. So let's just do this in this teal. So we have negative 3. And then for our second interval, let's just say we chose 2. And for our third one, we went from 3 to infinity. And let's just say we went with 5. So now in step 5, it's to substitute values into our derivative. Let's go ahead and do that. What I'm going to do is I'm going to move our critical points calculations off to the side. Okay, just make that smaller. All right, so our derivative was 6 times x minus 3 times x minus 1. Okay, so now let's go ahead and do section by section. So interval number 1, we chose the value of negative 3. Again, we just chose a value between negative infinity and 1 because that's our first interval. So we have 6 times negative 3 minus 3. We're just substituting our value we chose into our derivative as x. Okay, and then we have negative 3 minus 1. Okay, so we have 6 times. All right, so then we have 6 times negative 6 times negative 4. Remember, these are in parentheses. 6 times 4, PEMDAS. We have 24. 6 times 24 is 144. And so now that we know, and remember, we said that the sign of our answer or the sign of our value is what determines if it's increasing or decreasing. We got a positive 144, meaning that in our first interval, we are increasing. And if you can find one of the intervals, you should be able to know that they alternate. So we have positive, negative, positive, but you always want to check because you can always make a mistake in your calculations. So let's go ahead and put this calculation to the side. Okay, so now let's go ahead and do interval 2. So we're going to substitute in 2 into our derivative as x. So you have 6 times 2 minus 3 times 2 minus 1. Okay, so this means, and remember PEMDAS, we have 6 times negative 1 times 1. So now we have negative 6 times 1, which is just negative 6. We have a negative, meaning it is decreasing. All right, that matches up with what we just did. Now finally, let's go ahead and do interval 3, where we chose a value of 5. So we have 6 times 5 minus 3 times 5 minus 1. So we have 6 times 2 times 4. 4 times 2 is 8. 6 times 8 equals 48. And you can see that that was the same value we got up here when we did x equals 5. And we know that's increasing because it's positive 48, and it all matches up. So now our answer to B, let's just write it right here. Let's move this guy and make it a little smaller here. And our answer to B, we're going to write it in red again. So our answer to B is increasing from interval 1 and interval 3. So interval 1 is from negative infinity to 1. So we know that is increasing from negative infinity to 1. And it's increasing from interval 3, which is 3 to infinity. 3 to infinity. And now we also know our answer to C, because we know that it is decreasing from interval 2, which is from 1 to 3. So we can just write 1, 2, 3. And that's all the work we need to show for B and C. Now let's go ahead to question D. So in question D, it's asking what values are the relative maximum and minimum. In this question, we want to find the critical points again. Find the critical points, and the critical points are going to be the same since you have the same derivative. Your function isn't changing. Critical points, and then 2 is to sub values into original function. In our case, it's g of x, and you're going to see what this means in just a moment. So now let's go ahead and do that. Remember, our critical points were x equals 3, x equals 1. We got this by setting our derivative, which was x minus 3 times x minus 1. And we set this equal to 0. And we know that this is 3, because we have to make this parenthesis equal 0, we get 3. And here we get 1. Those are our critical points, 3 and 1. So now we're going to substitute both of these values into our original function. And if you remember, our original function was 2x cubed minus 12x squared plus 18x. So now we're going to substitute in 3 first. So we have 2 times 3 cubed minus 12 times 3 squared plus 18 times 3. So we know that 3 cubed is 27. So we have 2 times 27 minus 3 squared is 9. 9 times 12 is 108 plus 18 times 3 is 54. We know that 2 times 27, let's just move this to the side. We don't have enough space. Okay, so we had our 2 here. So we had 2 times 27 is 54. So 54 minus 108 plus 54. And then we can do 54 minus 108, which is just negative 54 plus 54, which gives us 0. So now we have a coordinate point of 3, 0. And we don't know if that's our max or min just yet. Let's just go ahead and find what the value is when x equals 1. Again, we're going to substitute in 1 to the equation. So we have 2 times 1 cubed minus 12 times 1 squared plus 18 times 1. 1 cubed is just 1, so we have 2 times 1. 1 squared is just 1, minus 12 times 1 plus 18 times 1, which is 18. So we have 2 minus 12 plus 18, which is negative 10 plus 18, which is just 8. So we have a coordinate point 1, 8. A good way to know which one's your max and min, you just look at the y values. The one with the higher y value is your max, and the one with the lower is your min. So let's write it in red right here. So our maximum is 1, 8, and our minimum value for our function is 3, 0. Pretty easy. Let's go ahead to our last problem, which says sketch a graph based on the answers above. So we're going to sketch it below as this arrow is indicating. So based on the answer, so what I like to do, let's just go ahead and do a light blue. Oh, okay, iPad. Let's go ahead and do a light blue. So here, what I like to do is start off by marking my critical points. And we said our critical points were at 3 and 0. So let's write 0. And then we had 1 and 8. So we have 1, 8, and we have 3, 0. Let's just mark those points really quickly. Let's do it in a different color. Let's go with this off-white, 1, 8, 3, 0. And now what we know is we can look at our B and C where we know it's increasing and decreasing. We said it's increasing from infinity or negative infinity to 1. So we're going to get increasing. And we want to draw the arrow because, again, it's infinity. And we know it's decreasing from 1 to 3. So we can show that's decreasing. And then again, it's increasing from 3 to infinity. And that is a really bad graph, but it looks something like, oh, okay. But in reality, it should look something like this, where this is your max at 1, 8. This is your min at 3, 0, and then you're going negative infinity and positive infinity. Infinity, negative infinity. I really hope this video helped. And if you believe it did, I would greatly appreciate for you to like and comment for any future video recommendations below. Thank you.